Okay, welcome to our channel. Thank you for always visiting this channel. And in case you haven't subscribed, please kindly subscribe, kindly like and share. And do not forget to click the notification button. So whenever we upload any new video, you will be notified without any delay. Thank you for coming. Today we'll be looking at uh, a new topic, and that's dimension in physics. Dimension simply means an expression of basic quantities to a power. That is, you are expressing a basic quantity, or what we call fundamental quantity, to the power in which they are derived from. Okay, and there are three basic dimension. Yes, we could have some extension, but three basic dimension to which quantities are being used on. That's M, L, and C. So when you see me using this is for mass, this is for length, and this is for time. And so we will be looking at them systematically. It's not as if there are no other that we can explain, but these are the basic that we will be looking at now. Okay? Questions? Find the dimension of acceleration 2. Find the dimension of momentum. Number 3. What is the units of pressure? So these are questions we want to quickly tackle. Now, answering this question is quite straightforward. So when you are given a question like this is a classic example of dimension. Okay, now you may want to know what's the purpose of dimension. When you get to the university, there is what we call dimension analysis. Okay, as I'm going to do something now, and so you will know the importance of dimension. Why do we have to do dimension? Okay, sometimes you hear that this quantity is a dimensionless quantity. It does not have a dimension. Okay, so pi, for example, pi is a dimensionless quantity. Pi, what you call 22/7, it has no dimension. Okay, now let's go quickly into solving of this. So we want to solve this now. So we have number 1, acceleration. So acceleration is known to be velocity, that is over time. Change in velocity over time. That's velocity over time equals to acceleration. Now the question is, what is velocity itself? Velocity is displacement over what? Over time. And so you may want to know what is the unit of displacement. Displacement simply means the distance moved in a specified direction. So distance with direction is called displacement. And the unit is the same thing as distance itself. Okay, so the unit is meter. The unit of time is what? Seconds. And so we come back to acceleration now. And so we have velocity to be equals to m over this. That's for velocity. And then you have this division sign, which is our time. And our time is in seconds. So my acceleration now is m over x multiplied by 1 over x, which is now what? M over s squared. Therefore, the dimension of my acceleration, I want to ask, what is the dimension of meter? Length, L. What is the dimension of second? Time, capital T squared. And so my answer now is either I leave it this way or I take it to indices. It becomes 2. That is, taking this up, then you have this as the dimension for your acceleration. So this becomes the answer to the question that we have just been asked to solve. Very simple and very straightforward. And in case it's not clear, drop it in the comment section. We go to number 2 very quickly. Solving number 2. Solving number 2. We are told to find the dimension of momentum. The dimension of momentum. Momentum simply means product of mass times velocity. Product of mass times velocity. So what's the dimension of this? Capital M. Or to make it simpler for you, let me first ask this way. What's the unit of mass? Kilogram. What's the unit of velocity? Is there? Look at it here. Meter per second. Then what then is the dimension, the quantity of this? What's the quantity of kilogram? Is M, mass. What's the quantity of meter? Is length. What's the quantity of second? Is time. And so our answer is now M, L, and this one can go up. It becomes -1. In case you're having issue with this, you may need to go through our loss of indices. It's on our channel. Check it out and then you will understand. Number 3, we're told to find the dimension or find the unit of pressure. Here we are told to find the unit of pressure. Number 3, unit of pressure. So the question is, what is pressure? Pressure is force per unit area. Pressure is force per unit area. And then what is force? If you are following and you have checked the former video, you will know that I did say that force is mass times acceleration. And then here you have the area. So force is mass times acceleration. And then here you have the area. And so what do we have here? Look at it. So my pressure, the unit of mass is kilogram. Acceleration, we have just done, we did it. Look at it here, it's here, it's still here. Is meter per second square. Area is meter square. That is length times length. So 1 meter can cancel 1 meter. So my pressure is kilogram multiplied by second minus this over 1 mlet. Therefore, the unit of pressure is now kilogram. The m goes up, it becomes -1, and then you have this. This is the unit of pressure. I'm sure it is pretty simple. And in case you are still having issue with this, kindly drop your concern, your question in the comment section, and then I'll be glad to attend to your question and clarify you. And if you are just coming to the channel, please hit the notification button and also subscribe so that you will always be following up our teaching on the channel. Thank you for coming. God bless you. Bye.